Okay, guys, thank you very much. Welcome back to the continuation of the lecture. So we have the question number 2. So the question number 2 is as follows. So we have the grade point average at a particular school is 2.89 with a standard deviation of 0.63. A random sample of 25 students is collected. So we are asked to find the probability that the average GPA for this sample is greater than 3.0. So you see, guys, in this problem, we are given the population mean, which is 2.89, and we know the population standard deviation is 0.63, and we know also the sample size, which is 25 students that have been collected. So now they are asking us to find the probability that the average GPA for this sample is greater, you see, greater than 3.0. So what we have said in the class is that in case where we are given the population standard deviation, so if the population standard deviation is known, so to find the probability that a sample mean fall in a particular region, so we use a Z formula. So if the population standard deviation is known, we use the Z formula. So if the population standard deviation is not known, we use the T formula. It's very clear. So now in our example here, the population standard deviation is known and the population mean is known. We have the sample size is known, and we are now asked to find the probability that the average GPA for this sample is greater than 3.0. So there is two key steps in order to find that probability that the sample mean will be greater than 3.0. So since we are using Z formula, so the Z formula is the sample mean minus the population mean divided by the standard error of the sample mean, which is simply equal to the standard deviation of the population divided by the square root of n. Now, in this case, we can now replace the value. We just replace the value by using the Z formula. So we will have this sample mean is 3. Okay, the hypothesized sample mean is 3. So we'll have 3 minus the population mean. The population mean is 2.89 divided by the standard deviation of the population, which is 0.63, which divide the square root of n. N is 25 students, square root of 25. So you will have 0.11 divided by 0.126. And you will get a Z value of 0.87. So now to find the probability that the sample will be greater than 3.0, knowing that the Z value is 0.87, so we use the table B1 in the appendix of the book that you have on the U-link. You just go in the book, just scroll down, and you will see appendix B, table B1, which is the area under the normal curve. Actually is the table associated to the standard normal distribution. And we know that the area under this curve represents a probability of 1. So if you divide this distribution into 2, a normal standard distribution has a mean equal to 0. So the probability in the left hand side will be 0.5 and the probability in the right hand side will be 0.5. Now, for instance, if you have a Z value which is equal to 1.96, so how can you find this probability, the probability associated to a Z value equal to 1.96? So you will just go here, you will see Z, and you go down, you have 1.9 here, you come to 1.9, 0.06 at the intersection of these two. So if you take 1.9 plus 0.06, you will have 1.96. And now the probability associated to a Z value of 1.96 will be 0.4750. And that is what you see here, 0.4750. Now, in our case, we have calculated a Z value equal to 0.87. So if you are using this table, so I will show you another way of using finding the probability. But if you are using this table in the book, I'm repeating it clearly. If you are using this particular table in the book, because there is another table that I will show you. So that is how you do to find the probability associated to a given Z value. So now in our case, we have calculated that the Z value is equal to 0.87. So what do? You go to the table, you go 0.8 and you take 7 in the intersection of 0.8 and 0.7, you have 0.87, and here is a probability. So a probability associated to a Z value of 0.87 is 0.3078. Okay, so now what you do, we are saying we are now here in the second step. After we have calculated the Z score, now we can now find the probability. So the probability of Z score to be equal to 0.87 is equal to 0.3078. Okay, now to find the probability that the average GPA for this sample is greater than 3.0, we will now take 0.0.50, which is the probability of the entire area here. Okay, so that's what we are saying. We will take now 0.50 minus the probability of Z score to be equal to 0.87, minus this probability, and we will have 0.1922. So the conclusion is that the probability that the average GPA for this sample to be greater than 3.0 will be 0.1922. But there is another way to find the same probability, but using a different table that I will also post on Ulink. Is that okay? We are asked to find the probability that the average GPA is greater than 3.0. So the table that we are using here is the following. In the second way, so is this table, which is almost similar to the first table, but it has, now here we are considering the negative values and the positive values. So, and here the table starts by negative Z score. So you have 0 here and you have Z score, and all of this part, the left hand side is constituted by negative value and the right hand side is constituted by the positive values. So here you have the negative values. So in our case, we are not concerned here in the negative values, but you have also positive values. So in the second way, we have Z score. So now the probability of Z to be equal to 0.87 using this second table here is 0.8078 is this probability. 0.878. So now what you do to find that probability, you will take 1, the probability of 1, okay, minus the probability of Z to be equal to 0.87. So if you determine this probability and we found that it is 0.878, remember here in the table, so the probability of Z to be is here. 0.87 is here. Here is the probability. Okay. So now remember here you have your Z and we found that Z is 0.87. So you have your Z here. Now they're asking us what is the probability that the mean will be more. It means that it will be in this region more than. So which is simply mean that we will have 1, because we know the area under this curve has a probability of 1. 1 minus this probability starting from Z, and you go in your right hand side. So which will be 1, the entire probability, minus this probability here. Or this probability is 0.878. So if you take 1 minus 0.8078, you will have 0.1922. So you have the same answer using these two different tables. Okay, so that is how you resolve this question. If you are asked to find the probability of a sample mean to be greater than a given number, so that is how you can determine that probability using these two procedures. For more clarity, let us take the question number 3, which is similar with the same question, but for more understanding. So here we have that the mean of the normal population is 60. So you have the mean, the average of the population is 60. The standard deviation sigma is 12, and the size of the sample is 9. So the probability the sample mean to be greater than 63 can be obtained as follows. So remember, in the question they were asking us to find the probability that the sample mean will be greater than 63. So because we know the standard deviation of the population, it simply means that we will use Z formula. So, and by using Z formula, we have the sample mean, okay, and the sample mean is always the hypothesized mean. You will have 63 minus the population mean, which is 60, divided by the standard deviation of the population, which is 12, divided by square root of the sample size, which is 9. So if you do this calculation, you will have 0.79. First procedure to find the probability that the sample mean will be greater than 63, we use this table, the table B1 in the area under the curve. Okay, so in that table, so we can now go and search what is the probability associated to a Z value of 0.75. We go in the table, so 0.7 is here and 5 is here. So the probability will be 0.2734 here, this probability. So that's what we have is 0.2734. Okay, so now to find the probability that the sample mean will be greater than 63, we will now have to subtract 0.50 minus that probability associated to a Z value of 0.75. So we'll take 0.50 minus this value. That's what we did here, and we have the probability which is equal to 0.2266. So another way is the following. The second way, if we want to use the other table, this table here, okay, is to just go straight to find the probability associated to a Z value of 0.75. And here we are. Here the probability is 0.7734. Okay, so we will now have to take 1 minus the probability of Z value associated to 0.75, which is this one. So it will then give us 1 minus 0.7734, and it will give us the same value, 0.2266. Very simple. So if you ask it to find the probability that the sample mean is greater, I'm repeating, is greater than a given value, you use, if the standard deviation is known, is given, you use the Z formula, and that is how you can find that probability using these two different tables. Okay, now the second question is that to find the probability that the sample mean is less than 56. Here it is straight. To find that probability, we use again the Z formula because the standard deviation is known. So we will have the sample mean, which is a hypothesized value, minus the population mean, which is 60, divided by standard error and square root of n. And we have minus 1.0. And that is why, guys, it is quite better for your understanding to use, I can really advise you in most of the case to use this second table here, because this second table you have both negative Z score and positive Z score, and you see that in this case we find that the Z score is -1. So if you go to this table, the table that you have in the book, that the table does not have negative values. It's only a table of positive values. Okay, and it's only repeating the area in the right hand side of 0. That's what you have those probability. So the best things to do, I will advise you, if I'm asking you this question, to just use the second table that you have negative values and positive values. So here we have found that the probability is minus the probability associated to a z, the z value is minus 1.0. So now we need to find the probability that the sample mean will be less than 56. If this is straightforward, is just to take that probability associated to a z value of minus 1. So that's what we are saying here, that the probability that the sample mean will be less than 56 is the probability of z will be equal to minus 0.1. And if we go in this table, okay, this table where you have negative z score, you will scroll down, you will see you have minus 1. And the probability associated to a z value of minus 0.0 minus 1.0 it is here, you see, because if you take minus 1.0 plus 0.0, you will still have minus 1.00. So it's 0.1587. That is what you have here, that the probability is 0.1587. Simple. So now find the probability that the sample mean is between 56 and 63. So that probability is 0.6147. So how did we found this probability? So this probability is found as follow. First of all, we will take the probability, yes. So first of all, we will take the difference, okay, between the 0.5 minus the probability of z to be less than 56, okay, which will have 0.5 minus this probability of z to be less than 56 is 0.1587. So if you do 0.5 minus 0.1587, you will have 0.3415, and that is what we have here, 0.3413 plus now the probability that the sample mean will be less than 63, which will be simply, okay, the probability of the z score to be equal to 0.75 to be greater than 63. So it will be 0.2734. So you have 0.3734. So if you add 0.3413 and 0.2734, you will have a probability of 0.6147. Just follow this procedure here and you will have the answer. So question number 4, which is also in the same format. So here I will be very quick. So the average value of the normal population is 75. The standard deviation is, again, no, is 5, and the size of the sample n is 40. So find the probability of the sample mean to be less than 47, to be between 74 and 77, and to be greater than 77. So I advise you always to go by starting resolving the question that is concerning either less than 74 or greater than 77 in order to find the between. Okay, so for the probability of the sample mean to be less than 74, so we just replace everything in the Z formula. So we have 74 minus 75, which is a population mean, divided by the standard error and square root of n, and you have minus 0.25, which is a negative value. And now we can find the probability associated to a Z value of minus 0.25. So we go in the table, we have 0.2 and 5 is somewhere here. Okay, 0, 1, 2, 3, 4, 5 here. So the probability, you see 5 here, so which is 0.25, is 0.4013. So you have here the probability is 0.4013. Simple. So now we can also find the probability of z to be greater than 77. So we replace everything, we get a z value of 0.5. Okay. So the probability of the sample mean to be greater than 77. So we go in the same table. Here we have a positive probability 0.5. 0.50 is here. 0.50 is here. Is 0.6915. So now we'll take 1 minus 0.6915 and we will get the probability. So we'll take 1 minus 0.6915 and we'll have the probability, which is 0.3085. Okay, and now to find the between, that the sample mean will be between 74 and 77. So we will first calculate the probability that the average probability of the area under the normal curve, which is 0.5, minus the probability of the sample mean to be lesser than 74, which is 0.4013. So if you do this calculation, it will give you a value of 0.0987. That is what you have here, 0.897 plus the probability of the z score. Okay, the probability of z to be greater than to be of z to be greater here. Yes, to be greater than 77. Okay, which is 0.1915. Okay, so this 0.1915 is obtained using this table, the area under the curve. So if you the probability of z to be z to be equal to 0.50 is here. So you will have 0.1915. So that is what you have here. That is what you have here. Okay, so now the probability of a sample mean to be between 74 and 77 will be this difference here, which is here, plus the probability of z to be equal to 0.5 if we use this table here, the area under the curve. So you see that you will have these two both table in order to get that probability. And that is what you have, and you will now finally end up by having a probability of 0.2902. So guys, master very well how to find this probability, because this type of question will be asked in your semester class test, semester test, and the exam. So I will come again with another series where I will show you how also you can use a T formula when we don't know the population standard deviation, how you can use this T formula in order to get the probability. So quickly, to finish with this tutorial, so you have this very long question. Let me take it, the last question, which is not really long, but it seems very scary, but there is nothing to worry here. So I'm opening the questionnaire. Here we are. This question number 5. Okay, so following a list of the 50 states with the number 0 up to 49 assigned to them. So you have a list of states. The first state starts by 0, which is the state of Alabama. So this is the state of the United States. And you have state 1 is Alaska, and so on. And you have 27 is Nevada, and up until you have 49. So if you take from 0 to 49, so you have 50 states. Okay, now You are asked, you wish to select a sample of 8 states from this list. So they're asking you to select a sample of 8 states, okay, randomly from this list of 50 states. The selected random number are, so they give you the random number are 45, 15, 81, 09, 39, 90, 26, 06, 49, 01, and 42. So now the question that is asked to you is, which state are included in the sample? So you are asked to select a sample of 80, and the random numbers that were selected are the following. So now construct a sample of 80, and now they're asking you which state will be included in this number, from this population. So, and the second question, that select a systematic sample of every 6th item using the digit 02 as a starting point. Select a systematic sample of every 6th item using the digit 0.2 as a starting point. Which state are included in your systematic sample? Okay, so now to answer this first question, which is the easiest question, you must pay attention to the selected random number. So you see here, I have the number 45. So I will now go and see if this number 45 is in my population. 45, I have it here, so Virginia. So the first state that will be included will be Virginia. Okay, I have 15. I will go 15. 15 is there. Is Kansas. Okay, Kansas State. I will include it. I have 81. 81. 81. So this 81 is not in my population. This number is not in my population. So I will not include this number in my sample. 9 is there. So it's Georgia. 39 is there. Somewhere there. South Carolina. 90 is not there. 26 is there. 6 is there. 45 is there. But you see here 45 is repeated twice. Okay, so I will not include it twice. 01 and 42. So actually the state that will be included will be 45, 15, second state. The third state is 9. The fourth state is 39. The fifth state is 43, sorry. And the sixth state is 29. The seventh state is 6. And the ninth state, the eighth state is 01. So those are the states that I will include in my sample. So it will be 45, 15, 09, 49, 43, 26, 6, 1. So, and you just count 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is what you have there in your memo. So I have summarized it. So Alaska will be included. Okay, so Alaska, which state is Alaska? So I will go and see. Okay, Alaska is state number 1. Why? Because 1 is in the random number that were selected. You see. So, and after Alaska, you will have Florida, Massachusetts, Nebraska, and so on. No, sorry, you have Alaska, Connecticut, Georgia, Kansas, Nebraska, South Carolina, Virginia, and Utah. Those are the states that will be included. So now, second question, question B. Select a systematic sample of every 6th item using the digit 02 as a starting point. Remember, we have said that in a systematic random, a KF number is selected, a KF starting number is selected, and every KF number, the second number will be picked up as part of your sample. And in this example, they are telling us that the starting point here is 0, 2, which means is 0, 2. 0, 2 is here, is Arizona. Okay, is Arizona. So that is your starting point. And now select, they are telling us to select every sixth item using the digit 2 as a starting number. So since Arizona is your starting number, Arizona here, so now we will start counting. After 6 number, after 6 district, the sixth one will be part of your sample. So now I can count 1, 2, 3, 4, 5, 6. So the second state that will be included will be Florida. So I will have Arizona, Florida, and I will again start 1, 2, 3, 4, 5, 6. It will be Iowa, okay, and I will start again 1, 2, 3, 4, 5, 6. It will be Massachusetts. 1, 2, 3, 4, 5, 6. Nebraska, and so on up until I will construct my sample of 8 states. Okay, so guys, that is how we resolve this kind of question. Also pay attention to this question. I'm advising you, because you may be asked a similar question and you must know how to do a systematic random. Okay, where a starting number will be given, and after a KF number, you will now start to pick states or country. It may be a country sample. So thank you very much, guys, to follow this video, and I think the practical we will stop here, and the Twitter will be available with a WhatsApp group that I will ask every student to join. So if you have any question related to this practical questions, you are welcome to ask, or related to the chapter itself, you are welcome to ask, and you can still have more clarity about how to do sampling and how you can use a central limit theorem in order to predict whether a given statistics is greater or lesser or between a given predicted value. So thank you very much, guys, for watching. Every question is welcome. So if you have you don't understand something, please, you can email me, or via WhatsApp group you ask the question and we can give you clarity. But please go through this tutorial, these practicals, because the question that I will ask you will be very similar to what you have here. So again, I'm insisting on how you use these two tables. So both tables, they will give you the same answer, but it will depend now in which procedure do you want to apply. But I'm advising you to use more this table, the second one here, which is very easy to apply. But the first table also is also easy. It depends with the process that you are taking in order to get the probability that a sample mean is greater or less than a given statistic that is given. Okay, so thank you very much for watching, guys.